Hello math enthusiasts and upcoming mathematicians. In today's video, we are going to solve a single problem in Calculus 2. And this problem has the propensity to give you an idea of how to solve any questions of this particular form. So without any further ado, let's begin the solution to this particular integral problem. Evaluate the integral of the square root of x plus the square root of x squared plus 2 dx. That's what we want to find. So before we begin, it is important that you know that this is an indefinite integral because it doesn't have a boundary. An upper bound and a lower bound is missing. So because of that, we say this is an indefinite integral. So we begin by using a substitution. We say let the entire square root of x plus the square root of x squared plus 2 equals to some new variable u, and we call this a u substitution. Great. Once we are done with that, the next thing to do is to square both sides of this equation. So to square both sides, we have this first square root cancelling, and we have x plus the square root of x squared plus 2 equals to u squared. That's brilliant because we could send this x across, and someone is wondering, when we send the x across, how do we hope to get our dx? Hold on, and let's do that. So we send this x across, we have the square root of x squared plus 2 equals u squared minus x. Great. Once we do that, the next thing we could do is to square both sides again to get rid of this square root. Remember, our goal is to find dx. So we square both sides again. We have x squared plus 2. So that's x squared plus 2 equals to u squared minus x all squared. Great. Now at this junction, we cannot go right ahead to differentiate because we have an x here. So the best thing we want to do is to expand the right hand side. So we have x squared plus 2 equals, we expand this, u squared all squared is going to give us u to the 4th. And then we multiply u squared by x, in this case negative x, is negative u squared x. And multiply the result by 2, we have negative 2u squared x. And then we square the last term, we have plus x squared. Great, that's the expansion of this term. And what we observe here next is that this x squared is going to cancel out this x squared because the both of them have the same sign and they are at different sides of the equation. So we send this across, they will cancel out. So we have 2 equals u to the 4th minus 2u squared x. Now, at this junction, we could solve for x by sending negative 2u squared x across. So this comes across, it becomes positive. It becomes 2u squared x equals to u to the 4th minus 2. That's what we have. And at this junction, we can solve for x. So to solve for x here, we have to divide both sides by 2u squared. So x equals u to the 4th minus 2 all divided by, this will give us 2u squared. Now we don't want to use the quotient rule, so we give each one of these their own denominator before differentiating. So x equals u to the 4th over 2u squared minus 2 over 2u squared. So we have x equals to, now u squared goes into u to the 4th, it goes u squared times. So this will be u squared over 2, and then minus 2 and 2 cancel out. This u squared goes in the numerator, it becomes u to the power of negative 2. Now at this junction, we can start to differentiate. If we differentiate x, we have dx equals, if we differentiate this, we have 2u over 2. This negative 2 times this negative is positive u to the power of negative 3, and this is du. So dx equals 2 and 2 cancel out, u This goes in the denominator, becomes plus 1 over u cubed, and then a du. If we simplify in here, we have dx is equals to, this time this is u to the 4th plus 1, all divided by u cubed du. Now we have dx, and we also have the entire integral, so we can go right ahead and evaluate this integral. So I'm going to rewrite the question. The integral of the square root of x plus the square root of s squared plus 2, and then dx. This is going to be the integral of, so according to our substitution, the square root of x plus the square root of s squared plus 2 is just u. So this is u multiplied by dx is u to the 4th plus 1, all divided by u cubed, and then du. Great. Once we have this, we can simplify. Simplifying, we have the integral of, so u goes into u cubed, it goes u squared times. So this is u to the 4th plus 1, all divided by u squared, and then a du. Giving each one of the numerator its own denominator, we have the integral of u to the 4th over u squared plus 1 over u squared, and then a du. This can be simplified as u squared plus, this can be simplified as u to the power of negative 2, and then a du. If we integrate u squared, we have u cubed over 2, and to integrate this is to add 1 to the power and divide everything by the new power, and then we say a plus c. So this is 1 over 2 u cubed. This is negative, so it's minus 1 over u plus c. Because the power is negative 1, it goes down, it becomes positive. But we know our u to be the square root of x plus the square root of s squared plus 2. Therefore, our final answer will be 1 over 2 parentheses, this is u cubed, so the square root of x plus the square root of s squared plus 2 all cubed minus 1 over, and this is u, the square root of x plus the square root of s squared plus 2, and then we have a plus c. We could rewrite our answer where in the entire thing is raised to a fractional power. So since this square root is 1 over 2, we have 1 over 2 parentheses x plus the square root of s squared plus 2 raised to the power of 3 over 2, because 1 over 2 times 3 is 3 over 2, minus 1 over parentheses x plus the square root of s squared plus 2, all raised to the power of 1 over 2 plus c. So thank you very much for watching this particular video, and if you have other questions you want us to look at in subsequent videos, please feel free to post them in the comment section of this video. Thank you very much for watching, and we see you in our next video.